In this video we're going to be talking about negative exponents, and I want to start with an example. I want to look at a to the 0 divided by a to the n. Now if we look at the quotient rule from the last video, what the quotient rule says is that we have two similar bases divided. What you can do is you can subtract their powers. That's going to give us a right-hand side in this equation of a to the 0 minus n. Now let's rewrite the left-hand side of this equation. We know that a to the 0 power, anything to the 0 power, is just 1. So really what we have is 1 over a to the n on the left side. And on the right side of the equation, a to the 0 minus n, well 0 minus n is just negative n. This says that 1 over a to the n is the same thing, it's just another way to write a to the negative n power. I'm going to rewrite the rule right here. A to the negative n is 1 over a to the n. And let's look at the example 3 to the negative 2 power. Well, the rule right here says that we can take that negative power and we can put the whole thing in the denominator and make the power positive. That becomes 1 over 3 to the second power. Well, 1 over 3 to the second power is 1 over 9. 3 squared equals 9. So we have our answer. For another quick example, let's look at a squared b to the negative first power. Well, a squared you can just leave as it is, but b to the negative first power can be rewritten. B to the negative first power can be written as 1 over b to the first power. So really what we have here is multiplying fractions. We have a squared over 1 times 1 over b to the first power. Well, multiplying fractions, you just multiply across the numerator. A squared times 1 is just a squared. In the denominator we have 1 times b to the first power. Now b to the first power we can just write as b, obviously, and 1 times b is just b. So that's how we simplified that answer. In many examples you're going to be instructed to simplify and leave negative powers out of your answer. So that's what we did here. We took this negative first power right out of the answer by moving the b to the denominator. Now let's look at another example. Let's say we have 1 over x to the negative 5th power. Now this first rule over here says that we can take the x to the negative 5th power and write it as 1 over x to the 5th. So we can actually rewrite this thing. We leave the 1 as it is there in the numerator, and we rewrite x to the negative 5th as 1 over x to the 5th. Now remember your rules about fractions. What we can do is we can think of the numerator as 1 over 1, and we're dividing fractions now. We have that whole rule. Sometimes people like to call it copy dot flop. You copy down the numerator, and you flip over, you take the reciprocal of the denominator, and you multiply. Clearly when you multiply that out, all the 1s are just going to go away, and you get x to the 5th power. So what we've decided is we can take a negative exponent in the denominator, move it up to the numerator, and call that exponent positive. So we can come up with another rule, which is really the exact same rule, just written a different way. And that rule is going to say that 1 over a to the negative n power is a to the positive n power. Now this might be getting a little bit confusing with all the negatives and the numerators and denominators flipping around, but really we have this thing down to one basic concept. And that basic concept is, if you have a negative exponent in the numerator, you can move it to the denominator and make the exponent positive. If you have a negative exponent in the denominator, you can move it to the numerator and make the exponent positive. Let's take a look at a couple more examples. Let's take a look at x to the negative 3rd power divided by 5 to the negative 2nd power. Now I just gave you the basic concept. If you have a negative exponent in the numerator, you can take that term, move it to the denominator, and make the exponent positive. You can do the same thing with this term in the denominator. You have a negative exponent, move it up to the numerator, and make the exponent positive. Now we have 5 squared over x cubed. Well, we don't know what x cubed is, it's just a variable. But we do know that 5 squared is 25. So our most simplified answer is 25 over x cubed. Now what we need to do is combine concepts from the negative exponent video, this video, and the previous video about rules of exponents. So let's look at this example. We have 2x to the negative 6y, the whole quantity to the negative third power. So the last video said that what we could do is actually distribute this negative third power to each one of these three terms, because all three of these terms are multiplied together. So we can write this as 2 to the negative third power times x. This is going to be negative 6th power times negative 3. It's going to be the 18th power, positive 18th power. We're then going to get y to the negative third power. Now we have two negative exponents left and we want to get rid of them. So 2 to the negative third can be written as 1 over 2 cubed. X to the 18th can just be written the way it is. And y to the negative third can be written as 1 over y cubed. Put all three of these together, and what we have in the numerator is simply an x to the 18th power. In the denominator we have 2 cubed and y cubed. Well, what's 2 cubed? That's 8. And y cubed. And our simplest answer is going to look just like that. And here are a couple tips for you. One common misconception: having a negative exponent does not mean that the answer is going to be negative. 2 to the negative fourth, if we follow the rules, is just 1 over 2 to the fourth, and 2 to the fourth is just 16. So the answer is just 1 over 16. That's a positive number. Even though the exponent here was negative, we end up with a positive answer. We could throw in some negatives though. We could say something like negative 4 to the negative second power. Negative out in front is just going to stay out there. So you end up getting a negative 1 over 4 squared, or a negative 1 over 16. Now this leads me to another point. And the point is that these two lines, the negative 4 to the negative second power, and then this entire negative 4 in parentheses to the negative second power, are actually two different things. In the top line, the negative 2 power is just on the 4, not on the negative sign. But in the bottom line, the negative 2 power is on the entire negative 4. So if we worked out this bottom line, it would look like this. You'd actually take the entire negative 4 in parentheses, and that would be squared in the denominator. Now anytime you square a negative number, as you know, you get a positive number. So this answer turns out to be positive 1 over 16. So keep in mind that there's a distinction between this first line and this second line. Along those same lines, if we had something like AB squared, that's a very different thing from AB squared. In the first line, just the b is squared, but in the second line, both the a and the b are squared. So the first line stays exactly the same. You can't really do anything to simplify it. The second line, if you're going to simplify it, it would look like a squared, b squared. So those are two different things as well. So just keep those things in mind. Let's look at one more example. X squared y cubed divided by z to the negative fourth, the whole quantity cubed. Well, as we learned in the last video, anytime you have a big quantity cubed, what you can do is you can distribute that cube, as long as everything is multiplied and divided inside the parentheses. So x squared cubed is going to be x to the sixth, because of the rules from the last video. Y cubed cubed is going to be y to the ninth. And z to the negative fourth cubed, because of the rules from the last video, is going to be z to the negative 12. We're just multiplying powers there. Now, in this video we said if we have a negative exponent, we can move it from the denominator to the numerator and make the power positive. So we're going to end up with x to the sixth, y to the ninth. We keep those exactly the same in the numerator. We're moving this term, this z term, up to the numerator, and we're making the power positive. And that's as simple as you can get it. Okay, here's your video quiz. Simplify these two and leave negative exponents out of your answer. Good luck, and I'll see you in class.